Hi guys, welcome to R Programming for SAS programmers. In today's lesson, we are going to learn about factors and list. So in the last lesson, we learned about vectors. If you need revision, click on the link on the top. So we learned that vectors are one-dimensional, and they store one type of information, one data type. So you can have like a numeric vector, character vector, or a Boolean vector. So all the values in those vectors are same data type. And we also learned that we have named vectors where we have name and value pairs in it. So we have such vector over here, the sex vector, which has a male and female value in it. So let's execute that one. I want to clear my console from the previous things that I did. So I'm going to press Control L, and that clears out the console. So I have the sex vector with named vectors. If I want to pull the values from the vector, we learned that there are two ways of doing it. Either we can give the position of the element. So here, in this case, I suppose I want to pull the first element out of the vector. Then in square bracket, I put number 1. Or I can use the name of the element and pull it that way. In both the scenario, I'm getting the same information in the output. So now let's see what happens if I try to add a different type of data type to a vector. So in this case, we have a character vector, and I'm trying to add a numeric value to it. When I do that, no errors in the log. R was able to take the value in. So let's see how R stored this value. And R stored it in double quotation marks, showing that it converted that numeric value into character. And if you look at the class of this vector, it is a character vector. What it tells is that R will automatically convert. If you have different data types in a vector, R will convert the whole vector into a character vector. So how do we stop people from adding different values or values that are not supposed to be there in the vector? How we can do a data integrity in our vectors. In our SDTM, we call it as control terminology. How do we make sure that only certain values show up in a vector or a variable? To achieve something like that, or to stop users from adding a different value into the vector or something that you don't expect the vector to have, there is a very special type of vector called as a factor. So let's see how you can create a factor. So to create a factor, let's first just create our regular vector with M and F values in it, male and female values. So we have 4 patients, 2 of them are male, 2 of them are female, and that's our sex vector. And then we're going to create a sex factor. So for that, you use a factor function. The first parameter is the vector, and then the second parameters are the levels. Levels are the distinct values that this factor can hold. So the only allowed values for this sex underscore F factor is M and F. That's what we are telling in this statement. So let's see how a factor looks like. And similar to our vector, we have the first row with all the values, and then the second row shows up the levels, the M and F. Now this level equal to, you don't need to specify this. It makes your code look better, but you can delete this out and execute it this way. So basically you have 2 vectors that goes as an input to the factor function. The first vector is the values, and then the second vector is the distinct values that the first vector can hold. So that's how the syntax goes. Now, just similar to our vectors, factors, we can fetch values using the square brackets. We can say first, enter, and then it gives me the first value and shows up all the levels again. Similar to vectors, we can overwrite values. Now here we are trying to overwrite the third value with a number, with number 1. Now let's see how things work on a factor. Now remember, earlier when on a vector, when we tried to add a numeric value to it, it didn't give us any error. It converted that numeric value into character and stored it. But over here, on a factor, when I try to add number 1 to it, it gives us a warning message that, hey, this is an invalid entry that you are trying to add into the factor. So that's how you can apply control terminology or data integrity on your vectors. And if you look at the class, it tells it's a factor class. Now in the sex example, we know that sex variable has a non-extensible control terminology. That means it can only have values m and f in it. But we know that in SDTM we have something called as extensible control terminology. That means the levels can have more values in future. It's not predefined what all values that vector can hold. So for example, if we have lab test codes, suppose a patient had 3 hemoglobin readings and 2 HCT readings on different visits. So right now, as of now in our data, we have 2 distinct values of test codes. But that's not going to be true forever. As the study progresses and the patient gets tested on other things, we'll have more test codes in our data. So our control terminology list is going to expand. So how do we add more values to our control terminology vector? So just like before, we have a lab test code vector where we have the data, and then we have the control terminology or the levels vector, which have the distinct values of it. And then we are going to create the lab test code factor by using a factor function. The first parameter is going to be our data, and second parameter is going to be the distinct values that vector can hold. So that's that. And if you take a look at it, again, we have the values in the first row and then the levels in the second row. So now let's see if, just like before, if we try to add another test code which is not defined in our levels, what happens in that case? Again, same thing. We get an error message saying that platelet is not defined as one of the valid levels in our factor. So how do we get rid of this message? So what you can do, you can use the levels function on the left hand side of your assignment, and then you can create a new vector with platelet information in it, and then you can assign that or overwrite the levels in this lab test code factor, and then you will be able to add this platelet, no issues, right? This time around, no issues. We were able to add platelet test in our test code because now it is a valid value. And then if you look at it, we got the last 2 values right over here. So that is how you can extend control terminology. Now let's take a look at something called as ordered levels. In the previous two examples, we saw that the levels did not had any magnitude in them. It wasn't like HGB is a bigger test than HCT or anything of that sort. But sometimes in our categorical data, we have different magnitude to the values. So for example, if we have a lab normal indicator, we know that low and low is the lowest value, then normal, and then the high. We know that they are ordered in that way. So when you see a lab indicator to be low, you understand that it is the smaller value. While you see a high value, you know it's a bigger value. So this low, normal, and high are ordered values. So what you can do when you define your factor is you can make them ordered as true or false. By default, the values are not ordered. So let's run this and see how does that help. So in this factor, we are going to create ordered as false, the default value, and then we're going to ask R to give us the minimum value from this vector. Now remember, minimum value of character, it's not going to be able to calculate it. So that's why it says, it gives us an error message saying that you cannot find a minimum value. But if we change the definition of our factor and we say ordered equal to true, and we give the order as this normal, low, normal, and high, and then we try the minimum function, we get low is the lowest value in the current factor. And this is how the levels are defined. Low, then normal, and then the high. All right, so let's try to summarize what we learned so far. We learned that factors are same as vectors. They are special type of vectors where you can apply control terminology to it so that only specific type of information can get into the vector and users cannot just put any value in it. We also saw that we can make factors as ordered. So then the levels have a particular grading to it. And we learned that vectors can hold only one similar type of data elements in them. It could either be a character vector or a numeric vector, or it could be a Boolean vector, like that. But what if you need to add different data elements? How do you do that in R? So you can do that in R by creating a list. So here is an example of patient profile. You create a list just like factors. You create a list by using the list function. And then in the parenthesis, you give all the different values. You can have something as an atomic vector, a character vector. You can have a named vector. You can have a vector with dates. You can have a normal vector without no named vector, just a regular one. And you can also have a factor in it. So this list contains a lot of different data elements in it. And when you execute this, you will see on the right hand side now, so far everything that we created was getting stored under the values values section. But this patient profile now got created in the data portion of the environment. And when we open it up, it shows us all the different data elements in it. One important point to remember in the syntax is when you're doing a list, you use an equal to sign to separate out the name and the values. Instead of using our less than and hyphen operator, you will use the equal to operator over here. So let's try to print our patient profile list. And you can see we have the same as vectors, named and values type of information showing up over here. If you just want to look at the names, you can use the names function on patient profile, and it will just give you the left hand side, which are the names of our elements. Again, just like vectors, if you want to fetch a specific value, you can give the number. So it will give us the second, in this case, it will give us the second element. And second element consists of two values, headache and fever, and they show up over here. Similarly, you can call that element by its name, which is AED code. So you can say patient profile, square brackets, in double quotation, the name of it, and it gives you the same value again. Or this is one more third way, where you can use a dollar sign, and you can give the variable name after it. So this is a more shorter way of calling the retrieving the values. So you will see this being used more and more in the coming up lessons. So let's look over here. Within AED code, if I want to capture only the first value, the first headache over here, how do I do that? So I use the name of the list, dollar, the name of the data element, and then within that, which index I want to point. So if I want the first one, and then only headache comes into the output. And I can also do call it by its name, because it was a named vector. I can use its name in double quotation and get it this way. You can convert a list into a vector by using the unlist function. So if you do like that, and then if you look at the pp vector, you can see everything has been converted into character. So you can convert a list into a vector, but you can see the date are a little bit messed up. It doesn't retain its formatting. So you have to be careful when you do that. All right, so that's the end of this lesson. We learned factors and a list in this practice. Like, subscribe to this channel so that any new videos that come up, you get the notification for it. And put in comments if you have any specific topic that you would want me to discuss in this videos, and show you any specific examples. All right, so I will see you guys in the next one. Bye.